There are many factors that can affect what goes on in learning. Most are even found outside the classroom. Each person is dealt a unique series of cards that they will use to decide their future, and one of these cards is their socioeconomic status. Abbreviated by SES, it is defined by the American Psychological Association as the social standing or class of an individual or group, which is often measured as a combination of education, income, and occupation. In most aspects of learning, especially in mathematics, this is important as a higher economic status may provide access to education opportunities, the absence of stressors, and a lot of influence from a person's parents. One could only imagine what the world would look like today if Isaac Newton needed to become a candle maker in the 1660s in order to make ends meet. Could he still find the time to discover calculus? Will the algebraic expressions that we use today still exist? Could he have studied math and physics at the Trinity College in Cambridge? In today's episode, I asked my friends if a socioeconomic status of a person is a determinant to their success in mathematics.
So let's talk about Newton and Leibniz controversy. Well, today, both mathematicians independently are credited for the discovery of calculus. There's a dispute over their claim of the subject, and it's become quite the controversy. What came to be are the following facts. Newton was the first to think of it, but Leibniz was the first to publish the discovery. So let's back it up with it to get to know these gentlemen. Sir Isaac Newton, he's a man of horrible beginnings. He's the only son of a not-so-huge yeoman, which places him higher than a peasant but lower than a lord. His father died before he was born. His mother shortly after remarries to a well-off minister who dies by the time he's 12. So his mother decides then, hey, might be a good idea to let Isaac take over and manage our properties. Then, his mother realizes how awful a caretaker he is and sends him back to school. Fast forward a bit, he goes to higher education, reads about Aristotle, Descartes, and the other smart people, and began writing his Questiones Quidam Philosophiae. Then went on to publish Optics and Principia, just about the two groundbreaking works in science, one tackling optics, the prism, and the other, the laws of motion. Then he gets elected as president of the Royal Society. So, a thing about Gottfried Wilhelm Leibniz is that he's well off, part of the so-called educated elites, being in a family of professors. He doesn't have an interestingly awful backstory. He goes to school, but since his father has this extensive library being a professor, Leibniz is very much largely self-taught. He goes to university at age 14, meets some other famous guys like Galileo, Francis Bacon, René Descartes. His other works other than mathematics mostly discuss about philosophy, since he comes from a pious Lutheran family. What he did do in science is that he founded dynamics in his warpath to criticize mechanics. Still, comparing that with Newton, well, he doesn't have this huge name for himself in the academic circle, so he isn't much noticed. So, controversy, right? See, it all started with this man, John Keel. Leibniz goes on to publish Acta Eruditum, which contains his discovery of calculus in the 1680s. Newton was said to have circulated within a circle what he found regarding series and fluxions in the 70s. In 1708, here comes Keel. Keel's this anti-Leibniz guy who accuses Leibniz of plagiarism in a publication of the Royal Society, which of course offends Leibniz, as he should, and asks for a formal apology to be published as well. In 1711, Leibniz demanded to be protected by the Royal Society from slander, since the ever-growing Newton supporters are all accusing him of plagiarism. Of course, being the president, Newton pulled some strings and wrote Commercium Epistolicum, where states that Leibniz had indeed received information from Newton's circle about frictions and then published the discovery as his own after changing the notation. Leibniz refutes this one, saying he had never gotten any correspondence with Newton. Now, cutting this long, gruesome story short, Newton, being the more renowned one, had acolytes to defend him. So, Leibniz, who died in 1716, spends just about the last of his days being accused of plagiarism, sadly enough. Another nice story is how Fermat's last theorem came to be proved is by Andrew Wiles. Fermat's last theorem states that there is no three positive integers a, b, and c satisfying a raised to n plus b raised to n is equal to c raised to n for all integer n greater than 2. Pierre de Fermat writes this in 1673 in his copy of Arithmetica, the book by Diophantine of Alexandria. For years, about 300 years, 3 centuries I think so, mathematicians had been looking for a proof of this theorem by Fermat. That is until Andrew Wiles succeeds in proving this problem in 1994. Andrew Wiles first discovered the theorem at the library when he was 10, and from that moment he knew that Fermat's last theorem is gonna bother him for a long time, that it was something he can never let go of. So he goes to quit his teaching job to dedicate just about 7 years of his life isolated in his attic of his 3-story Tudor house. He spends his whole time there looking for the proof. When he comes to prove the Shimura-Taniyama conjecture regarding elliptics, if I recall right, when he proved that to be true, it consequently proved Fermat's last theorem to be true. That's this Gregory-Perelman and Poincare's conjecture. Poincare's conjecture is among the 7 unsolved problems, hence called Millennium Problems. It only took Gregory-Perelman a year of complete devotion to solve it. Perelman was a natural genius at mathematics. When his mother saw that, she immediately enrolled 10-year-old Gregory to a specialized after-school program offering mathematics training. He was then enrolled to Leningrad Secondary, which offers advanced mathematics and physics programs. He went to compete in an international mathematical Olympiad, which he absolutely crushed with a perfect score, bringing home the gold medal for the Soviet Union. That achievement made him well known in the academic world in the USSR. In fact, he even didn't take the entrance exam for his university. They took him at face value. When he graduated with his PhD, Perelman basically became the most sought-after professor. Universities all over the world offered him research positions. After about quite some time, jumping from place to place, finishing projects after projects all over the globe, he realizes, damn, do I hate mathematics. He went to reject every offer. Then came Richard Hamilton, a professor at Columbia University, asking Gregory to take a look at the Poincare conjecture, which the latter developed an obsession to solve. For solving it, he was offered $1 million, which he refused. Later on, he was awarded what is the equivalent of the Nobel Medal in mathematics, the Fields Medal, which he also refused. Today, the genius is unemployed, living in a reclusive life, vowing never to do maths again after the Millennium Problem.
Now, what do these 3 narratives have in common, you might ask? These aforementioned great mathematicians who have contributed insurmountable discoveries and knowledge to the field of mathematics were those that came from the elite, or wealthy, well-off families. In all cases, they had available resources in which their mathematical ventures were funded. It is to be noted that the studies they conducted spanned over a long period of time and thus needed monetary support. The Newton-Leibniz dispute both agree and disagree to the point at hand though. Wealth-wise, Leibniz was wealthier in his upbringing, but status-wise, Newton is rungs above in the social ladder. This brings us to a very important point. Socioeconomic status is a determinant to success. This brings us to a very important point. Socioeconomic status is a determinant to success in mathematics. According to the American Psychological Association, socioeconomic status encompasses not only income, but also educational attainment, financial security, and subjective perceptions of social status and social class. In the case of the mathematicians, it can be said that they are those of a higher socioeconomic status. Socioeconomic status can encompass quality of life attributes as well as the opportunities and privileges afforded to people within society. Within these privileges lies the opportunity to learn and achieve great success in mathematics. In the famous Kuhlman Report of 1966, one of the significant findings was that socioeconomic status is the single most powerful predictor of academic achievement. This became a basis for multiple studies to be conducted, especially in English-speaking countries such as USA, UK, Australia, and New Zealand. One of these studies is that of Hernandez. The study aimed to determine if a significant negative relationship exists between the FCAT 2.0 mathematics scores and socioeconomic status for the years 2010 to 2011. With respondents from 59 public middle schools from Florida, the study found that as the number of low socioeconomic status increased, the percentage of students who passed the FCAT test decreased. This goes to prove Kuhlman's claim, in which socioeconomic has a great influence on success in mathematics. Further, Hernandez states that low socioeconomic status is composed of factors such as segregation, poverty, home ownership, parental influence, parental involvement, parents' education, and the family structure. These things negatively affect one's mathematical achievement. In the Philippines, a similar study was conducted in which factors that affected achievement in mathematics were studied. In an article by Lasha, student scores in the mathematics area of the National Achievement Test, or the NAT, was used as a measure of achievement. Two significant findings from this study were closely attributed to socioeconomic status. First, it was found that the father's highest level of education positively influences students' achievement in mathematics as compared to their mother's educational level. This implies that the father's highest level of education tends to influence their children to perform better in mathematics. Contrary to this result, Lockheed, Fuller, and Urango found that mothers' higher levels of education had a positive effect on mathematics achievement among 8th grade students in Thailand. It was revealed further that it is the father's professional occupations that positively influence students' achievement. These findings are closely attributed to socioeconomic status. As previously mentioned by the American Psychological Association, the level of education is determined by socioeconomic status. Second, it was also found that students achieve higher math scores if they are given the opportunity to learn by themselves. This is consistent with Kuhlman's report, in which socioeconomic status serves as a stepping stone to individual learning, and with this, educational achievement.
Moreover, several studies also showed that educational attainment of a person is influenced by their SES or socioeconomic status. Hence, today, the majority of underprivileged people are not literate enough when it comes to certain disciplines such as mathematics. Further assessments also prove that the success rate of low-income students in certain disciplines that is essential in everyday life, like mathematics, is relatively low when compared to those who have higher SES or those who are not part of the underrepresented background. The inadequate education received by these students in the low SES communities contributes to their academic progress. Hence, improvements in academic or school systems and intervention programs that will focus on these factors should be given importance. Although it may seem discouraging, but doing further researches on these matters, the correlation of SES and education is vital in providing a just academic system.